I'm newly the deputy CTO of Opera. If you're wondering how you can be a deputy chief, the answer is that allows you to do more responsibilities but no extra money. I'm an HTML alcoholic, and I first fell in love with the web. I'm an HTML alcoholic, and I first fell in love with the web in '99 when I was living and working as a primary school teacher in Bangkok. I got sick, and I was diagnosed with multiple sclerosis, and I couldn't find any English language information because in Thailand, like all the other equatorial countries, there is no MS. So when I got home out of hospital, and when I could walk again, I saw that across the road from my apartment there was an internet cafe. So I kind of Zimmer framed my way in and paid my 50p for half an hour and typed in multiple sclerosis into Alta Vista, which was like Google but steam powered. And I found this website called Julie's Joint, and it was a bulletin board of people from New Zealand, Norway, Scotland, South Africa, Canada, all with people with MS, all like helping each other through their diagnosis. People with different first languages, different computers, different operating systems, and I knew then that the web was a revolutionary new medium. So when I returned back to the UK in 2002, I started working at web standards, etc., and finally found myself as deputy CTO of a $1.2 billion browser company. But I've always been trying to make the web better. My pledge to the web is basically this. So all through my career, I've been trying to make the web better for developers, because I was a web developer and I love you, each of you individually. I want to make the web better for consumers, the people who actually use the websites that we make. Make the web better for business owners, because those are the people who pay you and pay me. And also many businesses exist now that could only exist because of the web. And I want to make the web better for the next 4 billion people who don't yet have web access, but can benefit from it as we have. You've heard this said, the customer is always right. It's a little bit of an unpalatable message sometimes, so I've kind of Helveticated it up and given it a moody image of Unsplash to make it nicer for you. Or if you're the kind of person who likes Facebook sharing, I've made it Facebook ready with some nice kerning and Comic Sans there. But it's true, the customer is always right. Let's go back to ancient times, 2004. Yes, there were hipsters in Shoreditch in 2004. In 2004, those of us who work in browsers, were scared. We were scared of Flash and we were scared of Silverlight. And so we came up with a spec called Web Forms 2 that later became called Web Applications 1, which later still became known as HTML5. This started with Ian Hickson in Opera. Now he works for Google. Mozilla joined us very early on. Then Apple. The W3C said, no, we're not interested in HTML because we're not interested in apps. Documents are the way forward, XML is the way forward. But we won the battle and it got called HTML5. And Hickson absolutely said, HTML is in direct competition with other technologies intended for apps deployed over the web, in particular Flash and Silverlight. Because Flash and Silverlight plugins, if you had an operating system upon which the manufacturer made the plugins, your rich internet application would work just the same anywhere, and you couldn't do that on the web. So we made the web better. But there's a new existential threat, Jean-Paul Sartre reminds us. It's not Flash and Silverlight, it is the apps of doom, native apps that are of the web and feeding off the web and arguably killing the web. So we saw this, we saw that people love native apps because you could do stuff with native apps that you couldn't do on the web. In 2009, if you wanted to access the GPS chip in your device, you had to use a native app because the web couldn't do it. So we we came up with a geolocation API. And then we had Canvas for scriptable images and native video, so you didn't have to have crashy plugins, an audio API, and WebRTC, the latest and greatest for peer-to-peer file sharing and video conferencing in the browser. But still, consumers voted with their feet. Today, the US consumer spends 2 hours and 38 minutes on smartphones. 80% of that time is in apps, 20% is on the web, said the analytics company Flurry in 2013. That got worse in 2014. It was 14%, 86%. Although we'd added all these new APIs to the web, it was still clear that consumers liked native apps. So we asked ourselves, what do consumers want? And the W3C convened a focus group. This is the focus group. Actually, this isn't the real focus group. This is an artist representation. This is the real focus group. And I have some audio of the conversation with us in the W3C. I really, really want to zig, ha. So, Tim Berners-Lee said, consumers were telling us something, we didn't know what they were saying. So we said, maybe it's a new API. We can't think of any, but there's this interesting one in HealthKit, the location rectum. Am I okay with the code of conduct there, Dan? Rectum's okay, good. So, teams of us on expenses scoured European capitals and looked in ancient mysterious bookshops. And eventually we found this ancient and mysterious dictionary. Well, actually it was Scott Jensen, who works for Google, who's kind of a Gandalf of the web. And he discovered what consumers were trying to tell us that we weren't giving them. And it was user experience. Those of us who work in browsers, those of us who work in web standards, tend to be, not exclusively, but tend to be engineering types. And we think in terms of features and APIs and things, and we forgot that user experience is a feature too. So what about if we had some magical combination of the reach and the capabilities of the web, the cross-browserosity, that's the technical term, the accessibility-osity, the publish and works anywhere-osity, with the user experience of the web. Well, of the native. That would be like this, wouldn't it? Game-changing. Thank you. I know that's shit. So progressive web apps. Progressive web apps is where we're at. Dan talked about them. Cleverer people than me are going to explain in detail how to make these work. But I'll give you the big picture. What consumers love about native apps is you install them to the home screen. Our consumers don't know what installing means, but what they perceive is they do something and they get an icon for that site on the home screen, not a browser icon through which they have to hunt and peck and find a previously bookmarked site, the icon for your site. With progressive web apps, this new thing we're talking about today, you can do this. You can allow your web app to be installed to the home screen with an icon. They can launch full screen, portrait or landscape, an immersive app experience. Progressive web apps allow you to do this. But crucially, they live on the web. The app is hosted on a web server. If you're as old as me, you might call this a website. And that's what they are. These are websites progressively enhanced to be like a native app on browsers and devices that can handle that. But on browsers and devices that can't handle that, it falls back to a website and everybody wins. So in Opera we did a brief test. We installed the native apps for these high-quality, popular websites. The cumulative storage space was required was 460 meg. The web app equivalent, cumulatively, was 1 megabyte. And this matters. As Facebook said, downloading a typical app with 20 megabyte APK takes 30 minutes on a 2G network. That's what most of the world have. 50% of the world don't have 3G network. And the download's likely to fail because of the flaky nature of the network. And the storage space matters. With space limited, the user's comparing their personal photo collection with the adoption of a new app on their phone. Your mobile device is probably the most personal device you have. If somebody ran off with your MacBook or your Windows machine, you could... other operating systems are available. You'd be pissed off if somebody ran off with that. But if somebody ran off with your phone, you'd be really, really bereft. And everybody's the same. In Africa, the World Bank did a survey. In Africa, people use their mobile phones for very personal things. Phone calls, text messages, missed calls. That's when you see a poster that says, for more information, send us a missed call. You call, ring once, and the company calls you back to save your money. Games, music, transferring airtime. That's a way in Africa of paying somebody by transferring an amount of airtime equivalent to the goods. And then photos and videos. People's devices are very personal, and if they have to choose between their own videos, their own photos, their own songs, or your app is going to lose. Birdly, in their rather sad blog post, Why You Shouldn't Bother Creating a Mobile App, said, "We didn't stand a chance. We were fighting with both our competitors and other apps for a few megabytes of room inside people's phones." So with progressive web apps, you don't download very much at all. You download basically a manifest file, which is tiny. You point to it with a link tag in your head, and browsers that don't understand this just pay no attention and render the site as a web page. And this is a perfectly valid manifest. It's small, very small. It's text only. It's JSON. This is a crappy demo site, demo web app. When you add it to home screen, in Opera for Android, you click that plus. In Chrome for Android, you choose the menu and add to home screen. Firefox are implementing this now, but I don't know yet what they're going to do, their UI. In Opera, you get this option, add to home screen, you choose it, you get this confirmation dialog. That name there has come from the manifest, the short name. And you choose it, and there it is, saved to your home screen. Not with a browser icon, with your site's icon. The icon comes from the icons member of the manifest. And then if you go to the task switcher, you can see that your web app is on the same footing as native apps on the device. It doesn't show itself as part of the browser, it shows itself as a fully fledged app. And that ribbon color there comes from the manifest theme color. So when the consumer starts it, they've got this on the home screen, they click it with a digit, up comes this, Wallet Connect, and then there's your app. Simple as that. On that splash screen, this icon is bigger because you've got more space, so it comes from that 192 member. The name comes from the name, you've got more space to show a longer name, so it's there. And you can choose to display standalone, so there's no URL bar, but you do have the status and the device's keys. If you want to, you can interrogate that in CSS. You can display it as a browser with a normal URL bar if you want to. I don't know why you would. Or more interestingly, you can say display full screen, and then you don't get the status bar and you don't get the browser keys. So you've got an icon on the home screen, the user tickles it into life with their digit, and up pops a full screen web app, indistinguishable from native app. You can display portrait, you can display landscape, and you can give a URL with a query string in order to track how many people come to your web app from the home screen. It's really easy to make a manifest. In fact, most of that information is probably already in your site in various horrible proprietary meta tags. So with a friend of mine, Stuart Langridge, I wrote a manifest generator that will scour your site and try to vomit out a copy and pastable manifest ready for you. And if you're interested in seeing some progressive web apps that are already in existence, PWA rocks. PWA.rocks is a community curated list of progressive web apps. Interestingly, lots of them are coming out of India and Indonesia, places with the lowest tech devices where storage and network connection really matter. Opera and Chrome by design implement this differently. We've been talking for 3 years very closely, and we're doing it differently to work out what's best. HTTP hosted sites will only display with the browser UI in Opera. Even if you as a developer say display full screen, we consider, or I consider, that it's so important if it's not secure that the user know where she is, that we will always show the URL bar. And if you follow a link that takes you out of the domain of the web app, Opera will spawn a new tab and show the browser Chrome. For the same reason, it's vital that you know where you are. Chrome shows like a little address. We don't implement the background color yet, it's coming soon. But what Chrome and Opera on Android both do is we reward really good progressive web apps. If it's secure, so it's HTTPS, if it uses a service worker, of which Junkie will tell you later, so it will work offline, and if the user has shown repeated engagement with your site, both Opera and Chrome will pop up a banner like this, suggesting to the user that she add it to the home screen. As a developer, you don't need to do anything, so it always looks the same. And this rewards really good sites. Flipkart is a big e-commerce site in India with big posh offices in Bangalore. A year ago, they closed down their mobile site and just pointed everybody to the App Store. So of all their consumers who've gone on a smartphone and typed in the URL and hit go, they were just directed to the App Store. Only 4% of those users ever downloaded the app. So they reversed policy and they went with a progressive web app. They're finding 40% returning visitors week over week, an increase of 63% conversions from home screen visits, which they can monitor with that query string in the manifest. And their consumers spend 3 times the amount of time that they used to on the website because it's an immersive, progressive web app. And they told me we want Flipkart Lite available on every phone over every flaky network in India. That's why they went with the progressive web app route. To recap, they live on the server, so there's no update distribution lag. The hardest problem in software, Alex Russell says, is distribution. With a native app, you have to upload it to an app store. That will alert your user. They have to download tens of megabytes, probably wait days or weeks in some countries before they can connect to Wi-Fi, and they may never download your updated app at all. Because this lives on the web, the moment you make a change, the next customer sees that change. So it requires no app store or gatekeeper. They're normal websites on Safari, Windows phones, and Opera Mini, which don't support progressive web apps. Because they're on the web, they're searchable, indexable, and linkable, and they can work offline. I'm not going to talk too much about this because you have in the room the man who co-wrote the spec for Service Worker, and I'm not worthy to talk about it because it's all like crazy JavaScript shit. But now, in a pre-Service Worker world, you go to a URL, happy birthday, Jake. Happy birthday, Jake. 40 today. You go to a website and you don't have connection and you just get a browser sorry message. That shouldn't be there. We thought we had this problem solved. Sorry, I thought I was doing a different talk for a minute. That should be there. We thought we had this problem solved. HTML5 invented app cache, but it is legitimate to say that if all the HTML5 APIs had a party, app cache would be the one not getting snogged, getting slowly pissed on little cider. The app cache API was a big mistake. It's the best example of not understanding the problem before specifying it, said Ian Hickson. App cache was great at what it did, but the trouble is, what it did isn't what you wanted. And because it's very magical, excuse me, you cannot really intercept how it works. Thus, it failed. Alex Russell, sinister mastermind at Google, said app cache is declarative. You give the browser a manifest and magic happens. This has well-documented limitations. They're well documented in this article. AppCache is a douchebag, written by Jake Archibald, ladies and gentlemen, the birthday boy who will be speaking later. I'm so impressed by Service Worker, I've put my legendary Photoshop skills to use and made this logo. Look at the cat. Look into the cat's eyes. Deeply into its eyes and listen to my voice. Use Opera. Wake up. So, without Service Worker, if you are not connected to the series of tubes that is the internet, you just get a browser-derived sorry message. But with Service Worker, and this is the level of my technical knowledge of Service Worker, with Service Worker, it sits in between your page and the network, and then you can choose to, when you are connected, store stuff in a special cache or in an index database, and when you're not connected, the Service Worker can, if you choose, there's no magic, you have to code it, it can drag stuff out of the database or the cache and give the user an experience. So for example, if you were writing a webmail client, of course you can't send or receive mails when you're not on the network, but the Service Worker could allow you to have a UI whereby you can compose mails, delete them, sort them into folders, all the kind of things that native apps give us that we haven't had on the web until Junkie Alex and Birthday Boy Jake got together with Anna Van Kesteren to make Service Workers. Hooray for them. They also give you push notifications, which are proven to enhance engagement as long as you don't send them every 10 seconds. And background sync. Background sync is really exciting, but I don't have time to tell you about it. But these are all symptoms making specifications now. This way is so exciting that I opened Photoshop once again and made this logo. It's called the Extensible Web Manifesto. And this is where my talk gets really, really meta. I'm going to be talking to you about a methodology by which we will probably make specifications. So if you need the loo or you just want to lie down, leave now. Why are standards so slow, said Mark Roberts to the WG, the HTML5 mailing list? Why is everything else around us developing so fast, but the web is so slow to adopt anything? Good question. Hixie replied, on the web, you have someone design the feature, someone spec it, someone write tests, have a browser implement it, have another browser implement it, etc., have people document it. In contrast with the everything else, native apps, which is simply someone implements it. If we are going to at least not win the war with native apps are a bridging technology, in my opinion, a bit like Flash, but there will continue to be some uses best served by native apps. Unfortunately. If we are to retain feature parity and at least have a development platform that is as attractive as the native app platforms, we need to move faster, and we need not to repeat the mistakes of AppCache, whereby people who don't write websites but do write specs design a feature that is actually of very little relevance to the people who are going to use it, you. So the Extensible Web Manifesto is co-signed by many members of the W3C Technical Architecture Group, but it's not an official ag document. Browser vendors, that's me and Jake, should provide new low-level capabilities that expose the possibilities of the underlying platform as closely as possible. And browser vendors should also seed discussion of high-level APIs through JavaScript implementation of new features. This is a great example, the fetch standard. Standardized specs written by Anna Van Kesteren of Mozilla. At a high level, fetching a resource is a fairly simple operation. A request goes in, a response comes out. The details of that operation are quite involved and used not to be written down carefully. Not written down carefully in a spec is a really terrible thing, because that can lead to interoperability nightmares, bugs, and you guys having to work late into the night, like 5:15 on a Friday, when you should be in the pub. Kesteren continued, the details of that operation, then not written down carefully and differ from one API to the next. These minor differences between APIs make it a lot harder for developers to learn, and that's not good, because you want to be in the pub instead of learning. So the fetch architecture provides a unified architecture for these features, so they are consistent. And crucially, it defines the fetch JavaScript API, which exposes most of the networking functionality at a fairly low level of abstraction. The point is, you can just use this, but if you want to, you can hook in and change it. It's not magic. You have to do it, but you have the power. There's nothing wrong with magic. Magic allowed people like me, when we first got into the web, to view source, copy and paste into Notepad, and type in things like input, and magically this box would appear. Or video controls, and magically some good controls consistent with the browser UI would appear. Or I could type in image src equals. I didn't have to know what was happening across the network. I didn't know the decisions the browser made if it encountered a PNG or a GIF or a GIF or a JPEG. I didn't need to know how it unzipped things. I just typed in those magic words and waved the angle brackets and abracadabra at it, and it worked. This was great. But you want to sometimes do things differently. You want to extend the web or make things happen that it couldn't do before. And you deserve to have that ability. You deserve to have that power. And that's what the Extensible Web Manifesto brings. I was a bit nervous. I was worried that this was heralding the JavaScriptification of the web. I really like JavaScript, however, it hates me, and I'm not very good at it. So I like declarative markup. I don't want to have to write everything in script. The Extensible Web Manifesto soothed my fevered brow. We want web developers to write more declarative code, not less. This calls for eliminating the standards bottleneck to introducing new declarative forms and giving library and framework authors the tools to create them. We've seen this in the selectors API. Anybody as old as me? Not as that? Cool. Everybody loved jQuery, whereby you could target DOM nodes by CSS selectors. And so Lachlan Hunt from Opera at the W3C wrote a spec to standardize that in browsers. Document.querySelector and document.querySelector all are directly inspired by jQuery and directly inspired by what the community, you, did, and then we standardized it and baked it into every browser. The W3C Technical Architecture Group, the TAG, see what I did there, they are involved in an effort with the CSS Working Group to extend the most arcane, the most mysterious, the secretest bit of all the web standards, CSS. Extending CSS is hard, but it's really important. The project is called Houdini. Harry Houdini was an escape artist. He could get out of locked boxes. And in his spare time, because he was a rationalist, he used to go around debunking the Victorian fad for spiritualism and mediums. He'd go to seances undercover and then publish how the fake mediums had duped people by producing ghosts, etc. So getting out of black boxes and explaining magic is exactly what Project Houdini wants to do. Thus, apply your CSS live as the page is still loading and reapply it any time the DOM changes. And this is hard. So one of the first things Houdini wants to do is give you insight into what's happening in the browser when it deals with CSS. Nothing in the browser will change, it's just you could never see what was happening. And to explain the magic, we need to give you a chance to see it. So the parser API will give you hooks into what your browser is doing with CSS. There are preprocessors and polyfills, but they aren't fully capable, they aren't fully compatible, they don't agree on the output, and any time the browser implements a new bit of CSS, you have to add stuff to the library. If you could just hook in and see what's happening under the hood, it will be better. They're working on a font metrics API. Sometimes you might want to do absolutely pixel perfect stuff, like lining the top of images with the top of a font. That's not too bad to do in English, but where's the top of that font with that accent? Or in, I think this is Gujarati, with the ascenders and descenders, where things can come both under and over the baseline. And don't get me started about drop caps in vertical text. Measuring this stuff involves copying it out into off-screen iframes and doing stuff with JavaScript. But the browser already knows this. So we're giving you insight into what the browser's doing. So then if you want to, you can do stuff with it. You don't have to. The browser will just carry on doing its stuff regardless, but it gives you the opportunity to see. Custom layouts. Custom layouts allow you to register a custom display value and then do stuff like CSS regions, which everybody seemed to love, but got dropped from Blink for performance reasons, in JavaScript. But you only have to do the new stuff that you want. At any point, you can hand control back to the browser for its heavily optimized C++ routines to deal with.